generally what we had seen so far, it was the basics and fundamentals of power electronics. So what is power electronics and what are the different applications? And we had also seen symbols of some PE devices and there be a characteristics curve. We did not see into the detail, but we had seen an overview. So today we will continue the basics. Now we will see different types of converter circuits. That is the goal of this course. So what different kind of power electronic circuits we are going to study in this course? These 4 circuits we are going to study mainly. So first one is called rectifier. So what the rectifier does, it converts AC input into DC output. So here you can see the input is a AC signal. AC means that is the sinusoidal. It's AC means what? It's alternate current. So AC signal we are giving, and at the output we get the direct current, that is the DC. So that is the purpose of this circuit, the rectifier circuit. So rectifier or AC to DC converter, it's called as a rectifier. So it's possibly it can control the DC voltage. Example, so where we are using these rectifiers, we use in traction control, battery chargers. Just one simple example is your mobile phone charger or your laptop charger. So you are getting 230 volt from your outlet. The rectifier, what the rectifier is doing, the adapter is having rectifier circuit. It's converting these 230 volt AC into whatever the desirable DC at the output. So it's also useful in DC drives, some kind of excitation systems, in synchronous machines, and so on. So this is useful in so many applications wherever we want to convert this AC into DC. So here you can see AC into DC. So the output voltage DC, right? This is the DC voltage. So this rectifier, we can also vary the DC voltage. Maybe because here, for example, some load needs 5 volt, some load needs 10 volt DC, some load needs 12 or 24 or whatever. So we can get the variable DC output. So the input is fixed. It's fixed as a 230 volt AC. So output we can get the variable DC voltage. So we can set up whatever the DC output we want according to the application. Of course, based on the device you are using inside this adapter, right? We are building this adapter circuit by using some PE devices. So whatever the PE devices we had seen just before, like it can be SCR, it can be IGBT, or it can be power diode or power MOSFET. Those devices are used inside. Based on the characteristics of those devices, so we can get either variable or fixed DC at the output. The second one is called chopper. So what is chopper? Chopper is doing the conversion between DC to DC. So you are giving DC as the input and you are getting DC as the output. So you can change and control the voltage magnitude. For example, here I give plus 100 volt DC. But in the output, I just only want plus 5 volt DC. So what I am doing here, I am stepping down. So this is called step down chopper, or we can also call buck converter. Sorry, buck converter is a step down. Have you studied about transformers? Transformers have step up transformer, step down transformer. Similarly, we have the step up DC to DC converter and step down DC to DC converter. Simply we call step down DC to DC converter as buck converter, and step up converter means what? So for example, now I have the plus 100 volt DC as the input. At the output, I want maybe plus 200 volt DC. So I am just stepping up the input voltage. So this is called boost converter. So because we are boosting the input to another level. So this is the chopper circuit, because what the chopper is doing, why we call this as a chopper. So whatever the input voltage we are giving, it's just to chop down and then either making it step up or step down. Okay, so we can change and control the voltage magnitude at the output. For example, where can we use these DC to DC converters? We can use in DC drives, we can use in subway cars, we can use in battery driven vehicles. For example, you have your car, electric car. Maybe some of you already have some electric cars or your family have that. So how the electric car is working? So in some portion, we need high or heavy DC voltage. In some parts, you need a lower level of or lower amount of DC voltage. So you need this kind of step up and step down converters. So this can convert and then it can give you the correct amount of DC voltage according to the circuit needs or according to the application you need. For example, in your car, maybe you will have a CD player. Nowadays, no more CD player, the radio or music player. So it needs a small amount of DC voltage. But when you start the engine, you need very high, more voltage to start the engine. And if you go in the uphill, you need more power. So you need to drive the engine more stronger. So everything is different types of load or different types of applications needs different amount of current, different amount of DC current. So this DC to DC converter is helping for such conversions. Third one is called inverter. What we are doing in the inverter, we are giving DC as the input. Here you can see direct current. DC means it will just be a straight line. AC means it's just going to be changing the current direction each time. For example, now this is the positive cycle and then this is the negative cycle. This is a positive cycle and this is a negative cycle. Of course, you put the reference line here. So above 0, it's called positive, and below 0, it's called negative. So it's alternatively changing the current direction. So now in this direction, suddenly it's just changing again to this direction in the negative side. The positive side, then it will be in the another direction. So alternatively changing the current direction. That's why it's called alternate current. And here it's not anything like that. So if this is the graph, if you write this is the 0 reference level, and if you draw the DC voltage, then DC will be just like this, just a straight line. So directly it's just going like this, the current direction. It's not going down and then changing. So that's why we call this as a direct current. You should know the difference between DC current and AC current, because we are using all the time these terms AC and DC. Inverter, we are giving DC as the input. We are getting AC at the output. So this is inverter, it's called DC to AC converter. Remember, this is AC to DC, that is rectifier, rectification. Here we are inverting DC into AC. So this is called inverter or inversion operation. So it produces sinusoidal of controllable magnitude and frequency. So for example, where we are using these inverters, we are using in UPS. UPS means uninterrupted power supply. And HVDC transmissions, it means HV means high voltage DC transmission. And we are also using these inverters in renewable energy systems. You should know nowadays this is a hot topic, renewable energy systems. Mainly when we talk about this renewable energy system, we are talking about the wind power and we are talking about solar power. Solar power means we are just getting from the sunlight and we are converting the light energy into electrical energy. Wind power means the wind is rotating the fan, the turbine. So based on the rotation of the turbine, we are producing the electricity. So that's why maybe when you drive the car somewhere North Norway, you might see this kind of wind power mills. So where they have a very gigantic fans, it rotates based on the wind and wind direction. And when it rotates, the turbine rotates in the bottom, and then it produces the EMF. EMF is converted in terms of electricity, current. So if we talk a little more into detail of wind power, how it works. In wind power, turbine rotation varies based on the wind direction. So turbine sometimes it rotates in one speed, and then suddenly it will be very fast, and suddenly it will be very, very slow. So based on this, if you produce alternate current, the frequency will be different. Sometimes you will have a low frequency, sometimes you will have a high frequency. So that is not what we want. We want constant frequency. So what we are doing now in these kind of situations, we convert the turbine rotation in terms of DC current, and then we are converting this DC current back to AC. So it means why we are doing this, it's very obvious, right? So you are getting very unstable frequency, sometimes low frequency, sometimes high frequency, like that. So instead of getting like this from the turbine, we are getting direct DC. So this is the 0 level, and this is the DC. So this one, by using this circuit, inverter circuit, that is going to help us to convert DC into AC. So now we are converting this DC into AC. Now we can, because of this circuit property, we can make a constant frequency. So that is good for us. That is what we want. So this is just one example how this wind power station is working, and how solar power. We are not discussing about solar power, but the similar concept. So whatever the energy we are producing, we are storing in terms of DC in the batteries, and then the solar power, and then we are using inverter, and then converting as a AC, and then we are using to our domestic load. In case if you are trying to have this solar panel in your home, and you want to convert into electrical energy, then I think you will definitely experience these circuits. You will use inverter. That inverter will convert the power. The fourth circuit is called AC to AC converter. Remember, here we are giving DC as an input and AC as an output. Here we are giving AC as an input and AC as an output. So this is called AC to AC converter. So here what we are doing, we can change and control the voltage magnitude and also the frequency of the output. For example, in USA, they are using 110 volt and 60 hertz. So you should know this is an international standard. Now this is the American standard, and some other few more countries are using this standard, but the rest of the world, they are using this as a standard AC voltage. So for example, Europe, most of the Asia, they are using this one. So here the voltage level is high, so the frequency is less. Here you reduce to the voltage amount and you increase to the frequency level. So if you travel to USA, you could see that they are not using the same plug point as what we are using in Europe. Okay, so now AC to AC, what we are doing now. So now, for example, I apply 50 hertz and 230 volt AC as an input. At the output, maybe I can get a 440 volt AC, and I can get 50 hertz. Or if I want to change the frequency, I can also change. Maybe I can make it as a 60 hertz if I want, or if any other specific value if I want, I can do that. So this circuit, AC to AC circuit, will help me to achieve that. So there are two types of AC to AC converters. First one is called AC voltage regulator. Another one is called cyclo converter. What this one is doing, so here you can see input and output frequency is constant, but voltage magnitude will change. It means I have 50 hertz, 50 hertz. Input frequency and output frequency both are constant, but I can regulate the voltage. So 230 volt, I can convert into 440 volt, or I can convert into whatever the volt I want. Maybe I can convert into 110 volt or something else. So you can change the magnitude of the voltage, but you are not changing the frequency. That is called voltage regulators. So where do we use these voltage regulators? We are using these mainly to control the speed of domestic applications like fans, water pump, or electronic, some other kind of, the fan regulators, where you are controlling the fan speed by adjusting the knob, electronic regulators. So all these circuits are using this logic, AC to AC conversion. So here both frequency is a constant in both input and output, but the voltage V is a variable. So you can change V as a variable. Second type is called cycloconverter. In cycloconverter, both output frequency and output voltage, both are variable. What it means? So here you are supplying some kind of input, that is the standard input. So at the output, if I want 110 volt and 60 hertz, yes, I can do it by using this cycloconverter. So here, what I did here, I changed the voltage magnitude and I also changed the frequency. So here both parameters are variable. So that is what I mentioned here, output frequency and output voltage, both are variable. But in voltage regulator, only voltage is variable. Here, a frequency is constant. So this cycloconverter, where do we use? It's useful in V by F control, that is the voltage divided by frequency, control of slow speed, large AC drives. So these are 4 major converter circuits which we are using in power electronics industry. So please remember this. This is what you are going to study mainly in this course. So the switching converter is the brain of the power system. Remember, power electronics, power system, it's two different things. Power electronics means power electronic devices we are talking about. By using power electronic devices, we are building the circuits. By using the circuits, we are creating the systems like wind power system, solar power system, and so on. So in all these kind of power systems, these switching converters, there is a power electronic devices, which is the brain, and it allows conversion of voltage and current levels with high efficiency. At the same time, you also have a control. So whatever the input you are giving, you can change at the output, either the output voltage or output current or output frequency. If it's AC means we also have a frequency. In DC, we don't have frequency, only voltage and current. Okay, so now you have some idea what are different types of converter circuits. AC to DC converter, it is called rectifier. DC to DC converter, that is called chopper. Third one is DC to AC converter, that is called inverter. So it's converting the DC voltage as an AC like this. And AC to AC converter is converting AC signal as an AC signal from AC to AC. Here AC is an input, AC as the output. So there are two types of AC to AC converters, which are AC voltage regulators. Another one is called cycloconverter. So please try to remember, this is the basic where we are going to start the course from now on.